Now we have come to the final video of the course. We need to discuss that the energy transition is not only a transition of energy sources, but a transition of the entire energy system. Let us begin by looking at the electricity system. You may have seen that in the future solar energy and wind energy are expected to become dominant sources of electricity production. But production of wind and solar energy is variable. They do not necessarily follow the demand. In this picture, we see a fairly regular demand pattern in red and a production pattern of renewables in blue. Sometimes these two lines match, but at other moments they diverge. In conventional power systems, the production plans follow demand, but with high shares of solar and wind energy, we need to find other means to match supply and demand. The key word here is flexibility. There are basically four options that can provide such flexibility. First of all, there is geographical flexibility. If we expand our grid infrastructure, it is possible to combine oversupply in one region with shortages in other regions. The second option is demand response. We can make the demand much more dependent on the availability of renewable energy sources. For example, we can charge electric vehicles at moments when there is abundant renewable electricity available. Another option is to apply storage. We first of all think of short-term storage, for example in batteries or pumped storage hydropower plants. But finally, we also will need backup or long-term storage, and that could be provided, for example, by fuels like hydrogen. Detailed modeling of power systems has shown that with a combination of all these options, it is possible to match supply and demand at any moment in time, and hence it is possible to maintain a reliable power system. But what we also see, that there is much stronger integration between supply and demand. That was already exemplified by the demand response option. But it goes further. If we need short-term storage anyway, why not use the batteries that will be available in our electric vehicles? This idea has been labeled vehicle-to-grid technology. At moments of limited supply, we can discharge the batteries in our vehicles and use them, for example, to feed electricity to our homes. This is a nice example of what is called sector coupling. Sector coupling is defined as the increased integration of energy use and supply sectors with each other. Another important system change is that we do not only have conversion of fuels into electricity through power plants, but we also use the process the other way around, the production of fuels out of electricity via electrolysis and other technologies. We already saw this in an earlier video. The fuels that we are using are changing. Nowadays, most fuels that are used in final energy use are natural gas, oil and coal. But in the future, different fuels will be employed. We already discussed hydrogen, but we can also convert hydrogen in other fuels like ammonia, methanol and synthetic methane. Next to that, we can produce fuel from bioenergy. A nice example are the so-called sustainable aviation fuels. So let me get to the summary. The energy transition is an energy system transition. The power system will develop from a demand-driven system to a flexibility-oriented system. We will see the introduction of sector coupling, where the demand side will play a much stronger role in power system operation. We will see a much bigger role for electricity and new intermediate energy carriers like hydrogen, and synthetic fuels take over the role of fossil fuels and their derivatives. And last but not least, we need to fully transition to energy sources that have no associated CO2 emissions. So to summarize, the energy transition is not just a transition of energy sources, but a transition of all the elements of the energy system. We have now reached the end of the course. In the last 4 weeks, we have covered the need for climate action, the various methods of energy and carbon accounting, we have explored the cost and potentials of emission reduction options, and finally in this week we have had a look at the essential elements of the energy transition. These elements are all essential in helping to design a climate-neutral future. But it is important to note that this MOOC serves as an introduction, and there is of course far more complexity involved with these topics. If you wish to go into further detail, we recommend you look at the other courses in this MOOC series. Details will be provided after the video. So thank you all for following along. We hope you have enjoyed this MOOC and that you can use the lessons learned to help achieve a climate-neutral future.